Okay, cool. So today we're going to talk about machine provisioning. Let's see what the right approach here is. Oh, these are nice. Okay. Davis, do you mind taking... Oh, wait, no, you're recording. Could you take photos of all this stuff before I delete it? Has nobody noticed that there's a big fat crack in this table?
That's why they try to stick it together with these little bolts.
But like... All right, whatever. Oh yeah, one of those. Okay. So how do machines come and go? How do we define various types of machines? And how does all of that work? Stu, first and foremost, if you go to this view, the view that you've been to probably many times, which is the list of our EC2 machines, you'll see that there are many machines that we run on. How do we make sense of, right now you can see at the top it says that we have 348 EC2 instances. How do we make sense of what all that stuff is? Hello. So a fundamental feature of EC2 is that all of the machines that you bring up, you can give them tags. So tags are just key value pairs that are a component of the metadata of any individual machine that comes up. We specify those tags. The mechanism by which we specify those tags, we'll review that today. But the key point is that they exist. The very, very first thing to notice, and the very first sort of like the most global way in which you can split these machines is by looking at the stage tag. There is a stage tag, and it is two things. It is either QA or production. And this GUI very helpfully allows you to split them in such a way. There's a filter by tags. You can just start typing in stage, select stage, and then it'll give you the choice of production or QA. So if you just wanted to look at all the QA machines, you can do stage colon QA up here.
How do you select it so it gives you the choice?
If you select the tag, it gives you the choice, yeah.
Like clicking on it, or is it?
Yeah. Here, let me show you again.
If you press enter, it just
Like if you do, yeah, exactly. So if you click stage, it gives you this. And then over here is the list of all of the things that are already the possible values of all the tags of all the EC2 instances out there. So once you've isolated your the stage, you can then start splitting the machines further by there are two things. This is a bizarre separation, but we have something called a machine type, a machine class. And the way to think about these is that types are roots and classes are leaves. What do I mean by that? Sidekick machines are probably the easiest way to understand this. Let's go to stage, production, and then do tag keys server type, like this. So this says attachment conversion, and this says premium sidekick. So this should say attachment conversion sidekick. But the type is server type is going to be server underscore type, server underscore class. So type is what sort of software runs on this machine is the best way to think about it, right? So server type is many different things. It could be app, cron, Docker, Elasticsearch, Kafka, load balancer, logging, memcached, Mongo, Neo4j, blah, 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 blah. You can look at all of them by just keep on hitting load more. Server class. So the way to think about it, server type actually defines what software runs on those machines. Server class is academia level usage of that software, right? So Sidekick runs on all Sidekicks, but we further split Sidekick by which class of Sidekick runs on that machine. But that distinction is purely for us, for academia employees, whereas type actually determines what is physically installed on that machine. So you'll notice that server class, all of these server class entries look like this. Academia zoo, : let's say, app, or, premium sidekick or something like that. Why is that? Well, because this string, the things that goes into the server class entry, is actually a Ruby class that is defined somewhere that represents in code these machines. Where might you ask, is that? If you open up the zoo repo, academia-zoo, and go to lib / academia zoo types, which is a directory folder. Inside, you will see a couple of .rb files, or not a couple, more like a dozen, that represent the various types of machines that we might have. So for example, if you click on sidekick.rb, you'll notice there are definitions for all of the different types of, for all the different classes of sidekicks that we may want to bring up in EC2. And these classes have various attributes that we define in Ruby code that specifies, for example, what size of the machine is it. Like, for example, most of our sidekicks are M4.x large, except for ring send email sidekicks, which are C4.8x large. They're much bigger machines. Send a lot of ring emails. And also, for example, CLI underscore identifiers. What is that? That is the string, that is the command line identifier for when you want to bring up a new one of these machines. So for example, bin zoo production add bin/zoo production add scraping sidekick is the command that will bring up a new EC2 instance and will give it a server type of sidekick and a server class of scraping sidekick, because this string is here under CLI underscore identifiers. Okay. Let's see what else we So, okay.
So
yes.
for a given server type,
Yes.
sorry, for a given server class rather,
Yes.
I don't see the server type specified anywhere. Is that something you have to supply to the binzu command?
You don't see the server type tag.
Oh, yikes, there it is. Thanks.
Yep. So, yeah. Okay. Now, why does this matter? Well, you want to be able to figure out how many different types of machines you have, what their split is. Sort of the advantage of being able to group machines should be vaguely explanatory. Let's see. So, how do we create a new one of these? Like I mentioned, if you'd like to, you can just run binzu production add some kind of sidekick machine, and that will bring up a console and start spinning up a thing. How does it work? Well, AWS has a API that you can, via various calls, bring up machines, tear them down, auto-scale them. What is the wrapper that we use for this API? It is called Fog. Fog is a generic Ruby client cloud library wrapper. Generic Ruby cloud library wrapper. And then, so this is a gem. Then on top of that, there are various included gems that you can, there are various related gems that you can include. So for example, we heavily use fog-AWS, which is the Ruby gem that plugs into Fog to talk to AWS. There's also, as you would expect, fog-GCP, or whatever it's called, fog-Azure, and a ton of less well-known cloud providers out there. Cool. When you start bringing up an EC2 machine, you have to specify a couple of specific things to make it accessible for you. So there are an instance, when it comes up, it must have associated with it a key pair. So this is to allow for SSH access. An AMI. So what's an AMI? AMI stands for Amazon Machine Image. AMIs are stored in S3 and are just the hard drive image of a virtual machine at the time of its startup. We use Ubuntu 14.04 and 16.04 AMIs. So what does this mean? Ubuntu is a particular Linux distribution that we run. You may or may not know that Ubuntu has a particular set of rules around their distributions and how they maintain them. Ubuntu has 2 releases per year. They always happen in April, so month 4, and in October, month 10. Right, and so the version number of a particular Ubuntu distribution is just the year and the month in which it was released. So we run on 14 and 16. Why those 2 in particular? Well, because there's a special rule for Ubuntu releases that happen on an even year in month 4. These are called LTS releases. LTS stands for long-term support. And what that means is that they provide security updates to those distributions for 5 years going forward. That's why most places that you find that run production machines, if they run Ubuntu, they run one of these 14.04 or 16.04.
What is LTS again?
Long-term support.
So are we going to make it 1904 or whatever?
We will never be on 1904. We may in fact be
when
on
1904 happens, will we be totally on 1604? Because there's that 5-year period.
Yeah, so right, when 1904 comes out, we will have a mad scramble to upgrade all of our 1404 machines to 1604.
We're not going to upgrade them to 18? We're going to go to 18?
No, because this is, well, before I speak too soon, we might do a few machines in 1804 just to see what it would be like. We already run a bunch of 1604 machines, and so that's not a big problem for us. We don't have any 1804 machines at all. Like, I don't know what the new incompatibilities there are.
Are the advantages of moving to a different Ubuntu version or a newer one, are they just security, or are there performance or API advantages?
Right, so sure, new kernels come out every new version has new kernels. New kernels usually mean better performance and more features. Also, it means more up-to-date packages that are actually part of the Ubuntu distribution rather than stuff that you hand roll, which means that you get, for example, newer versions of curl, which we don't hand roll, we just apt-get install directly from the Ubuntu distribution and so on and so forth. Like most things that are a little bit secondary, we just get them directly from the Ubuntu repo rather than hand roll our own. Yeah.
Are these done by server type? Which version of Ubuntu they have?
Yeah, so we, by default, let me see if I have this. Yeah, if you go to postgres.rb, which has Postgres files, which has Postgres server classes defined, and you scroll down to, for example, line 40, you will see that there is a Postgres read slave, and it says Ubuntu _release Xenial. So these things also have names that are not just the time and date when they were released. So this thing is called Xenial. Full name actually is something else.
16.4 is called Bionic Beaver.
Right. So 1604 is called Xenial Xeris. I don't know what that means, but that's what it is. Here, if you don't believe me, it's right there.
They all sound like sci-fi.
It's
Yeah.
an African ground squirrel, apparently.
Yes. And I believe 1404 is Trusty. Yeah, is that?
Guitar.
Yeah, Trusty Tar. So, you might ask, okay, well, what about 1410? Whatever started with PQRSTU. What's wrong with it? Well, support for security for non-LTS is, I believe, 2 years. So the release train there is a little bit more aggressive. So how do we know, here we have this thing called Ubuntu release Xenial. How do we know what Xenial is? What is the actual AMI for that? So if you go to config and AMIs.json in Zoo, is a big fat JSON dump of all of the Ubuntu AMIs with their versions, plus various configuration components that are supported that, so for example, AMIs are different in various regions because AMIs are stored in S3, and S3 is region specific. So if you're bringing up a machine in US East 1, the same exact configuration for that machine is going to be different between US East 1, sorry, the AMI for an identically configured machine will be different between US East 1 and some other Amazon region. And the file that we use to translate type and distribution and region into the specific AMI is this file right here. Cool so far? Yeah.
And then where does this file come from, sorry?
This file comes from a script called update_AMIs.json, which is in and of itself it does a whole lot of processing, but the original place is this location called cloud-images.ubuntu.com. So basically, Ubuntu, they maintain a set of AMIs themselves, and they publish them.
So they maintain the AMI values?
Yeah, they maintain the AMI, like they maintain the list of AMIs. Like, so for example, the fact that in Northeast 1, precise AMD 64 that it boots off of EBS has this particular ID, AMI 121D2B75 or something like that. That's provided by Ubuntu.
Not Amazon?
So, well, the ID is generated by Amazon, but the AMI itself, like all of the stuff that's on the hard disk, Ubuntu creates it, but then uploads it to S3 on Amazon, right? Does that make sense? The question is, so okay, there's something called Amazon Linux, which we don't use, except in one situation, the LDAP server. Why? I don't know. What? Right. LDAP, the protocol, is a Microsoft thing, but we, in order to run it, we provided it runs off of Amazon Linux, whatever. Every provider, we're promiscuous like that. That's cool. So Amazon creates their own Linux distribution. It's actually a CentOS, which is actually a Red Hat RPM thingy. I think it uses something called Yum. I don't know why. Let's see. What else? Right. So we're on 14.04 and 16.04 right now. And we specify that via the Ubuntu release tag in types.rb, in like postgres.rb rather. And that under the covers translates that into some AMI ID over here via AMIs.json, which is a set of AMIs provided to us, a set of AMI IDs that are stored on Amazon but maintained by Ubuntu. Okay, cool. So I started talking about this component and security groups. Okay, so that's enough for now about AMIs. Let's talk about security groups and key pairs. Key pair. So when an AMI comes up, Ubuntu did a nice job, and they already enable your ability to SSH in. But in order to keep that secure, all of these AMIs have support for, as soon as the VM starts coming up, they put the public key of, they put some public key. You know how all of this stuff works, right? You have your private key on your machine, and that means that any machine out there that has the public key, you can SSH into it. Yeah, cool. So you upload your public key to Amazon, and you specify, okay, bring up this AMI, put this public key into it so that then I can SSH into it with my private key. These key pairs are specified on the command line, but they are in fact themselves stored here. Key pairs under EC2. I should really clean a lot of this crap up. And that would be ideal. George is still in here for reasons unknown, and _academia. Yeah, definitely gonna clean this up. Nobody here has met George, right? No. George Bashi. Have you met George? Have you met George?
Maybe.
Okay. Right on. George Bashi did a lot of insane infrastructure work here at academia. Many insane things that you see are maybe due to George Bashi, or maybe due to a George Bashi modification of a less insane thing prior to that. He runs infrastructure at EAT24 now, so you know, good guy. I like him. So you specify a key pair. Usually, the key pairs that we use for machines are app_production.pem and app_QA.pem. I don't remember what PEM stands for, some very specific version of a security certificate. We distribute these to most people that join, but these are actually sort of the root access keys to all of the machines. And we may, in the future, be a little bit better about giving these out. By better, I mean a little bit more restrictive. Because we already give everyone access to these machines via their own key pairs during provisioning. More on that later. So the key pair that's specified when you bring up a machine isn't like everybody that can access to it. It is the original key, like it is the root key, because later on you can add users and you can add their keys. So for example, for like, as far as I can tell, for example, I'm pretty sure that this James is actually not James Fisher. This is probably James Pettit.
That's a good rule of thumb.
Yeah. So, for example, like the four of you don't have your keys listed here. Why is that? Because we don't use our regular developer keys as the initial key that we use to get into the machine, because these machines are part of production, so you don't want the root key to be an individual person. You want the root key to that machine to be like a standard key. And the fact that the standard key is app production is just encoded in zoo when you run this command, bin zoo production add scraping sidekick. That code, if you're at some point curious, is probably in commands. Actually, no, it's not in commands. Lib academia zoo. Server.rb probably, yeah, this. So this determines who can SSH, who is the holder of the private key that can SSH into this machine the very first time after it comes up. The next set of things to worry about are the security groups. Security groups are an Amazon-provided feature that allows you to restrict incoming and outgoing traffic based upon source and destination IP plus ports. So if you've tried to log in from home, you might have followed these instructions that I've posted somewhere about how to add your IP address to a security group called Office and then run Terraform apply. That's to get around this particular Amazon firewall feature that specifies a specific list of IPs that could SSH. So like security in depth, right? You must have the correct key pair to get in, and you must be coming in from a allowed IP address in order to get in.
Is it possible to spoof an IP address?
For UDP, yes. For TCP, no.
Okay.
And you don't SSH over TCP. Over UDP. So it's not going to work. Okay. Any questions so far? Yeah, okay. So I did this. Oh, okay. Let's see. So you specify all these things, and eventually the machine comes up. And you can SSH in with a predetermined key. What happens next? Well, next happens there's two things that happen. One is setting the name tag for this machine, as well as its DNS entry and its host name. So. So, okay, first and foremost, a name for this machine is generated. What is a name? Well, the current scheme for that name is server underscore class, then birth date, then random word from a dictionary, and then dot, and then if it's QA, then scholarific. If it's production, then zoo, and then .us or com. So once this name is generated, it has to be put into 3 different places. One, we want for this name to be the DNS entry so that when you SSH into it, you can actually SSH to this name rather than to some IP address that is randomly assigned by Amazon. So, oh yeah, an IP address is randomly assigned to this machine when it comes up. Also, a Amazon-generated DNS name is assigned to this machine when it comes up. That Amazon-generated DNS name is usually based upon the IP. So, for example, you will usually have seen it like over here, public DNS IPv4, and then it tells you that it's like EC2 dash whatever the IP address is dot amazon.alias.com. I'm talking about this entry right here, right? So that's Amazon generated. And all of the instances that we have are accessible via that DNS entry that's Amazon generated, except that it's extremely user unfriendly as far as we're concerned. So we generate a name, and then we take that name and we go to the Amazon Route 53 service, and we register that name to its either the Amazon provided DNS name or to IP address. I don't remember which is which, but let's just say that that works. I think it's actually to the Amazon generated DNS name. So in Route 53 name, so let's call this the academia name, and we map it to the Amazon name, Amazon DNS entry. So that's one. The second thing that we want to do is we want to give this same academia name as the name tag on this EC2 instance so that it shows up nicely in here. That's thanks to the name tag over here. This, by the way, is a common feature of most things on Amazon. If they have a tag, if some resource on Amazon has tags, then chances are if you set a tag whose key is name to some value, that value will then be used for the name column in the standard view for that Amazon dashboard.
Can you say that again?
Yeah, yes I could. So you see this column, this name column?
Yes.
There is no special thing called a name for an EC2 instance.
Oh, okay. We don't have a name by default.
They don't have a name by default. This entire thing is just it's a hack. If it has a key called name, then it just is populated from there.
Is this something that most places would do, is to provide a name like this?
Yeah, most places in Amazon, if they have an ability to specify key value pairs, then the name key actually means something special. It means the name, but it's all provided via tags. There is no special attribute called name that you set separately. I've seen this in other places, like for example, security groups have names, and security group names are set via the name tag, or something like that, remember. Wait, no, security groups don't have tags. Some other things have tags, so where the name actually means something special. Okay. Okay, so we set the name tag. Great. And then a third thing that we do is we set the actual host name. So remember, when you SSH into one of these machines, if you've done that, if you've SSH into one of these machines, you'll notice that this thing is there, right? It actually tells you the academia name of the machine at the shell prompt when you SSH in. that doesn't just happen magically, because usually what that shell prompt uses what's called the host name in Unix. That is like set in a file called /etc/hostname or something like that. And so the third thing that we do once we generate an academia name is we SSH into this machine and write the academia name into /etc hostname so that basically this machine knows what its own name is. This is also why it is very hard to change a host name of a machine once it's been brought up. Because these are the three places where this happens, and I remember these three. I don't actually know all of the little nooks and crannies where we might write the host name of that machine at some point later in the process, or when it's being provisioned, or for some special piece of software that we use on only some subset of machines somewhere. OK, great. This thing now has a name. What's next? The next thing is we provision the entire thing with Ansible. You undoubtedly already have experience with Ansible when you've set up your VM. The dev environment is also provisioned via Ansible. Right. Ansible looks like this. It is a big fat YAML file, or a collection of big fat YAML files. What is so special about Ansible? Well, one, it can run across. So how does it work? OK. There's a YAML file called a playbook, or a series of YAML files that can be together looked at as a playbook. Ansible, a unit of work in Ansible is called a task. So for example, a task might be something like copy a file, or I don't know, start a process or something like that. So let's see, what do I have here that looks like a, yeah. Here, for example, this is an individual task. What is the idea behind tasks? Tasks are supposed to be idempotent. I don't know how do you say this word. How do you say this word? Idempotent. OK. Idempotent. Yeah, exactly. So what does that mean? It means that when you execute a task multiple times, the end result is the same as if you had only executed it once, except a little slower. And Ansible tries very, very hard to tell you whether a particular task, such as copy a file, did work or didn't do work. So after you do a big Ansible run, if you've ever done one, you'll see at the end it'll tell you number of changed tasks and number of, I don't remember what the other one was, successful or something like that. or not changed, let's say. I don't remember what they use this in Ansible. Let's see if I have a good example of how this works. No, for sure. Here, I just resized a bunch of Postgres machines yesterday, I think, because I was on vacation, but some people dropped the ball on a few alerts, and I had to log in. It's funsies, and resize a couple of Postgres machines. So in order to do that, I run an Ansible playbook. Here, let's review, for example, what an Ansible playbook looks like. This is my command to run an Ansible playbook. Man, this room is really missing a monitor.
Jack, do you want to come to the other side of the table?
Yeah.
Does anybody know when there's going to be a thing in this?
Aren't there a pile of TVs sitting in the storage room, or do those go somewhere else?
I swear to God, this is like the episode of The Wire, where the teacher goes to the basement to find out all these PCs that were unopened, and like all these most recent versions of the textbooks that were just in big piles of books.
Maybe we could have this if it's just this many people in one of the rooms does have a.
Well, I didn't know how many people were coming, but yeah. Okay. So, task. Here's an individual task. And when you see a task that ends in OK:, what that means is Ansible did work and decided that there is nothing to do, not changed. And then there's further on down, for example, over here, Ansible did work and noticed that there was something to do, that it changed. There are some exceptions to this rule, which means that like something, like if you run some command for which there is no way to determine idempotency, whatever, it'll always come up as changed. That's just like a limitation of what Ansible can do. But like in 99% of the cases, Ansible tries really hard to tell you whether something changed or didn't change on a file system after a playbook run. A playbook is composed of tasks at the most broad level. There are actually further subcomponents in here. There's something called a play. So a playbook is a sequence of plays. And then there are also something called roles. And a play may or may not include roles. But that is like advanced Ansible that we don't need to cover over here. Anyway, suffice it to say that we run an Ansible playbook called site.yaml on a new machine that comes up. And site.yaml is smart in that it includes every playbook for every type that is out there. So it includes all the playbooks for Postgres, and it includes all the playbooks for app, and it includes all the playbooks for Sidekick. But it sections them out. In other words, it determines what type of machine we're running on and only runs it on that type of, and only runs a Postgres playbook on a Postgres machine, only run an Elasticsearch playbook on an Elasticsearch machine, and so on and so forth. So, why bother with Ansible? Well, as opposed to shell scripts, for one. So the idea is that Ansible is supposed to The idea is that Ansible is kind of like SQL in that you specify what you want to happen, but not how you want it to happen. There's like an underlying engine that figures out what is the best way to add a line to a file, or to like copy a file over, or to do whatever it is that you've specified it to do. So that is, implementation specific. The performance of that may improve over time. The performance of your bash script is unlikely to improve over time, but as new versions of Ansible come out, things may improve. So Ansible greater than bash because declarative. Of course, that doesn't prevent you from writing a bash script yourself and then creating an Ansible task whose entire job is to run that bash script. And we've done that many times in situations when Ansible provides a task to do something, but it isn't quite the right fit for what we are trying to accomplish. Yes?
Is there a robust Ansible plugin system or community?
Robust. Yes, there is a robust community, meaning that there are some plugins that are quite excellent, and then there are some plugins that are barely maintained.
Sort of like Terraform.
Sort of like everything. Sort of like every open source project that has a plugin system and has reached some level of popularity. Questions so far? Was this mine? Was this yours? This one. I'm out. I'm parched. Let's take a 5-minute break. All right. So we have talked about Ansible. I think the next thing would be to maybe walk through how exactly site.yaml works for Ansible. So this is what happens when an entire machine gets provisioned after we do a Binzu add on it, or it is scaled up via an auto-scaling group. Can I have a blueberry? Thank you. Mm-hmm. For each correct thing said, so let's pop open site.yaml in Academia Zoo. There is, so it's a YAML file, so it always starts with 3 dashes, because all YAML files start with 3 dashes, for whatever reason. What?
I don't think they have to.
They don't?
Yeah.
Well, why the hell? Why is that there? Yeah, okay. All right. That's weird.
YAML's weird.
Okay. So, okay, there is a bunch of okay, so which part here is interesting? All right, so there's a bunch of preamble stuff in this playbook that isn't particularly interesting to concentrate on. Let's go to the part that line 13 says something like this: hosts, all. What does this mean? So, remember I said Ansible has a way to distinguish. So first of all, Ansible can run one playbook on many machines at the same time. And these machines that it's running this playbook on could very well be of different types from each other. So that means that when you write your playbook, you're thinking, okay, this playbook might actually be run across my entire cluster, all of the machines on it. This component that I'm writing right now, is this component of this playbook supposed to run on all the machines or on just some subset of the machines? So each individual Ansible play, a play is a chunk that has a hosts : entry and is either a set of tasks or a set of roles. Each individual play, which hosts does it run on? So, for example, the very first play inside .yaml runs on all the hosts that you may want to run this playbook against. And what does that mean? It means that all of these include lines from 22 all the way to 36, include facts.yaml, include osconfig, include apt, mnt, tools, cup, sysadmin, repo, etc., etc. All of these files that are included, they all execute against all hosts. So, for example, let's take a look at what happens when we do include apt.yaml. So pop open apt.yaml. So in here there is many different lines, but one of them is include apt.yaml. And if you open up apt.yaml, this is a playbook, or rather a playbook snippet. And it has an entry that says role : apt. What does that mean? Roles are Ansible components. Oh, hi. No? Are you coming on Thursday? No. Hey. Right. What is an Ansible role? An Ansible role is basically, think of it as a function call. It's like an abstracted piece of work that you can apply to a machine. In this case, apt.yaml, the fact that this is called apt and this is called apt, well, that's nice, but they don't actually have to be the same. Any playbook here can include any role. It's just that there is a playbook named apt, and it happens to include a role named apt. Maybe not the best example to start out with. There we go. A better thing to first look at isn't apt.yaml. Let's first look at tools.yaml. So on all of the machines that we have, we install, for example, Ruby. Right? Everyone has tools.yaml open? You. No? Cool. What's the very first thing in tools.yaml? Roles. Academia. Ruby. And then, if you go to roles, you'll see, so right next to tools.yaml, there is a subdirectory called roles. Inside that subdirectory, there's going to be a subdirectory called academia-ruby. And inside academia Ruby, there will be a bunch of stuff, defaults and tasks.
There's just tasks in this one, it
Hmm?
Where are you?
Oh yeah, default is empty for you. Okay, that's fine.
roles/academia Ruby/test.
Oh.
And so when you include a particular role, what that actually does is it includes the main.yaml from roles that name tasks, right? And what does main.yaml do? It installs the academia Ruby that we compile ourselves and upload to GemFury, right? If you open tasks main.yaml, you shall just see on line 3, install academia's build of Ruby. So what does that tell you? Hosts all includes tools.yaml, which then includes academia Ruby. That means that we install academia Ruby, the package that we compile everywhere on all the machines, no matter if we provision them or not. Doesn't matter if it's app or Sidekick or Postgres or Sensu or Kafka or anything else. Academia Ruby is always installed on it, as well as many other things that are provisioned via tools.yaml. Contrast that with, for example, what you see on line 38 in site.yaml, right? So now let's open up site.yaml, line 38. And what you see there is hosts : app. That means that that play only runs on things that that have server type set to app. How exactly does Ansible know that app is a server type of ours? There is something called an Ansible inventory. Kind of a complicated subject, but it basically converts our tags into groupings of machines. Davis knows all about that. So in this case, for hosts app, what do we have? We have role Rails, role Unicorn, role Nginx Unicorn, role Bruce, and role Instance Health Check. What does that mean? That means that those 5 roles, so remember what are roles? Roles are chunks of Ansible code that we run. Those 5 roles get installed only on app machines. And then you can scroll down inside that YAML, and you'll notice that there are many different hosts, lines that group various machines together. Cool. Let's see, what else? Okay. We've mostly covered everything that is in the notes from last time. We can trace through how do we add EBS volumes on the very bottom. Let's do that. So, real quick, open up site.yaml. Find the line that says include postgres.yaml. What does that mean? That means that you have to then open up postgres.yaml. In Postgres.yaml, you will see all of the different server class machines that we have that are of type Postgres listed in hosts : lines. Do you see what I'm talking about? Line 6, line 11, line 17, line 24, all of these are hosts : line with academia zoo __, and then some Postgres class that we have. That means that each one of these chunks just applies to an individual Postgres class when we bring up some machine of that particular Postgres class. So let's take a look at the very first one, the one that says, not the very first one, the second one, the one that says setup main Postgres. This is what happens when you bring up the main database or a replica for the main database, right? This is what we covered last time before I went on vacation, database replication. So how do you bring up a new replica? Well, you run bins of add Postgres master, and what happens is eventually it falls into here, into this chunk. This is the chunk I'm talking about, if not obvious. Postgres.yaml lines 10 through 14 or so. Then the next line is Postgres-main. It says host : academia zoo __ Postgres master roles Postgres main. Who can tell me what roles : Postgres main does?
Executes Postgres main / tasks main.yaml.
Let's go there. It's not there. I gave you incomplete information. There is also a thing called meta main.yaml that a role can have. And in it, you can specify a list of dependencies for that role. So just like a function can call out to other functions, a role can depend on other roles. In this case, Postgres main depends on, by the way, guys, I'm here for those that are falling behind, Postgres main / meta / main.yaml. So what is the dependency here? It's role Postgres with some EBS specific things. But what does that mean? It means you have to now find the Postgres role. And if you go find the Postgres role and open it up, that thing looks humongous, right? This is the Postgres role right here. It is under roles Postgres, and it has both defaults and files and handlers and meta and tasks, and it's got like 8 different YAML files for tasks. And so this is the the heart of the star, or whatever sci-fi analogy you want to insert here. The exhaust portal on the Death Star, I don't know, whatever. So what happens here? The first thing is you go look into meta main YAML because that's where the dependencies are in Postgres. And there you see, oh, we set up Postgres common, we set up Sensu client notifier, so that when we install Sensu, we know about it, logs, and we set up has EBS volume. What is has EBS volume? Has EBS volume is a role that we wrote that, given an EC2 instance, attaches some EBS volume to it. So that's like how the data volume gets attached to Postgres main.
So are we looking at Postgres main / blah 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 / main.yaml or
Postgres Postgres /, right? So Postgres main is just a thin pass-through to the Postgres role.
Okay.
and you have to look to Postgres slash meta main, and then you look at Postgres slash tasks slash main. Cool. Questions? No questions. Cool. Done 25 minutes early. Nice.
Or that all we need to know about EBS volumes?
EBS volumes was just an example of a role invocation. I mean, there's a lot to know about EBS volumes. And, well, for you specifically, there is a lot more to know about EBS volumes. But, like, for a general overview, probably sufficient.
Okay, Mr. Question about anything. I had a question back to slightly tangential, related to, like, the Benzu stuff.
Yes.
And the Terraform book that you're having me read. So is that something that would be, that the Terraform could replace, is the Benzu stuff?
Yeah, so the idea is something like this. Benzu is currently it does a lot of work. Currently Benzu production add actually does calls out to AWS and does add instance, and then set DNS, and then add security groups and all of this stuff, right?
That would be the same API that Terraform.
And so this stuff is stuff that Terraform should be performing for us. It's just that this predates Terraform. Now, does that mean that we will completely get rid of the Benzu production add? Probably not, because what we want is we want to enforce so Terraform is highly flexible. It will allow you to do anything with your infrastructure. Terraform doesn't know anything about server type and server class tag distinctions that we've set up. That's our business logic on top of infrastructure. And so what we would probably do is we would keep these commands such that they generate Terraform files that obey the conventions that we've set up, so that you can't write some piece of Terraform infrastructure that doesn't fit the general paradigm that we've set up of server types and server classes. Does that make sense?
Yeah, so when you're adding stuff, we wouldn't, in general, be editing Terraform directly and generating
Yeah.
new Terraform stuff.
So what advantage does moving to Terraform bring us in this case?
So what is the fundamental advantage of Terraform? It is that there is source code, and the source code has a one-to-one mapping with what's currently in AWS. When you did Benzu production add scraping Sidekick, and that Sidekick machine came up, there is no record in any source code that you, in fact, did this. Right? You just ran a command that did some work. And then once you've closed your terminal, even the history of you having done that command is now gone. So there is no correspondence. Right? So the advantage of adding Terraform in this case is that this will generate a Terraform file that says, bring up this scraping Sidekick machine. And then you check in this Terraform file into source code. And then when you apply it, it brings up the scraping Sidekick machine. Cool. Yes?
So I remember before you and Sergey were talking about custom AMIs.
Yes.
Can you talk about what that means or how that workflow works?
Okay. So what does Ubuntu do to generate these AMIs and upload them into S3? You create EC2 instance, so box. You do work here. You make this machine look like the sort of machine that you would like to bring up. You run some kind of, save to AMI command that takes the hard drive here, packages it up, uploads it to S3. So we do a lot of work when we provision machines. Right? We install the same stuff over and over again. Like we bring up a new Ubuntu AMI. Ubuntu AMI doesn't know anything about Academia Ruby, so we install Academia Ruby. We install all the users. We install a ton of other stuff. It's a source of problems because it takes time. So if, for example, a lot of traffic is coming at the site out of nowhere, and you start spinning up a new app server, provisioning takes about 10 minutes, 10 to 15 minutes. So there's 15 minutes when you're under high load and serving and turning away some requests because you can't handle the load. So one solution to this would be, well, like, why don't we just have an AMI that is an Academia AMI rather than an Ubuntu AMI? Why don't we just create a new one? And as soon as it comes up, it already has our code on it. So you turn on the machine, and it immediately starts serving the Rails app. No provisioning, nothing. Just like it's the right machine. It looks exactly like an app server, except that that is at the AMI level rather than having to run an Ansible playbook at it. Right. The advantages of this seem kind of obvious. This is hard. Why is that? Because it means that every time that somebody, for example, does a deploy, we have to regenerate a new AMI with the latest Rails source code base. Anytime that somebody modifies an Ansible playbook, we have to regenerate all the AMIs that we might use for all the different Sidekick machines to regenerate them. So this is hard, but it is a good end state to aim for. Yes?
Can we go like halfway?
Yeah, that's the plan. Yeah. Cool. Does that sufficiently answer that question?
Yes.
Okay. Cool. Thank you.